Welcome back, everybody. Happy Monday, May 4th. May the 4th be with you. Happy Star Wars Day. Today, we're going to be talking about comparing quadratic functions. This is an Algebra 1 video. So I'm going to be looking, when I'm comparing functions, I'm going to be able to look at two different quadratic functions, and I'm able to then compare some type of feature. Remember that features are like y-intercept, concavity, x-intercepts, local min, local max. I can also compare behavior, and also I can compare specific inputs and outputs. And today we're also going to be touching base on comparing average rate of change. So this is something is how fast is this function increasing, or how slow is it increasing or decreasing? So I'm going to also be able to compare average rate of change. So I'm going to write this in a different color because we've seen this before, but I want to give you the average rate of change formula. Remember, it's literally the slope formula, but because we're looking at a quadratic function, it's the analysis of the difference between two outputs, all divided by the corresponding difference of the inputs. So that's the average rate of change formula. I'm going to leave it there so that we have it for reference. And I'm going to go ahead and start with two functions, and we're going to compare them. And so notice that I'm going to compare these two functions, but my comparison is going to be in the middle, okay? And the comparison is going to be my, is it less than, greater than? So that's why this is in the middle. So I'm going to start with over here, I have f of x equals x squared plus 2x minus 3. And over here I have g of x is equal to 2x squared minus 4x minus 30, okay? So I'm going to look at a couple things. First, I want to know is y-intercept. Who has a greater or y-intercept? So remember that the y-intercept is f of 0 for both of these. We recognize that they're in standard form. So I'm going to go ahead and find f of 0. So f of 0 is going to give me 0 squared plus 2 times 0 minus 3. Remember, I am just simply replacing the input to become 0 from x. So wherever there's an x, I'm now replacing. So I know that f of 0 is equal to 0 because 0 squared is 0 plus 2 times 0 is 0 minus 3. I get that the y-intercept for this function is at negative 3. We're going to go ahead and do the same thing over here. So I'm going to go for g of 0 equals 2 times 0 squared minus 4 times 0 minus 30. This gives me g of 0 is equal to 2 times 0 minus 0 minus 30. So this gives me that g of 0 is equal to 0 minus 30. So I regular here, I have g of 0 is equal to negative 30. So here I'm able to say that the function of f has a higher y-intercept because the output here is negative 3 versus this y-intercept is at negative 3. So I'm going to say that the y-intercept of f is greater than the y-intercept of g. That's our first comparison. I'm going to also talk about concavity. So let's talk concavity. So here, my a for f is 1 because there's no, this means 1x squared. So my a is 1. Over here, my a is 2. So this is going to open like this because it's still greater than 1. However, this one is going to be a bit compressed because my a is greater than 1. So it's going to have a faster rate of change. So here, they are both concave up, but this one's going to have a greater concavity than that one. Okay. Good little review of all the prior topics we've been doing. Now I'm going to go into specific inputs and outputs. So let's look at a specific, or let's look at the axis of symmetry, okay? So if I look at which one has a higher axis of symmetry, right? So I'm going to look for axis of symmetry. And my axis of symmetry, remember, it's x equals negative b over 2a. So first, I'm going to look for that value here. I recognize my a is 1. So I'll write it here. A equals 1. B equals 2, C equals -3. I'm going to do the same thing over here. A equals 2, B equals -4, and C equals -30. So I'm going to go ahead and plug that in here. I have x equals -2. My B is 2, but it's a negative on the formula. Over 2 times 1 gives me -2 over 2 gives me -1. So I know that the axis of symmetry is at x equals -1 for the function of f. And let's go ahead and see what the axis of symmetry is for g of x. So again, my B is -4, but now I have a negative here. So notice that this is going to be -4 over 2 times 2. This gives me negative is positive. 4 over 4 gives me 1. So here I have x equals +1. So for this one, the axis of symmetry is greater for this one because remember the axis of symmetry is looking at the input value, which is going to create a vertical line. So that one's going to be greater. However, let's look at the vertex now. If I'm looking for the vertex, remember the vertex is now, I'm going to figure out using this axis of symmetry input value, plug it into the function to find the actual output that corresponds to the vertex. So I'm going to look for f of -1, which is going to give me -1 squared plus 2 times -1 minus 3. This gives me 1. -1 squared is +1 minus 2 minus 3. This gives me -1 minus 3, which is -4. So this is my vertex right here. F of -1 equals -4. I'm going to do the same thing over here. The axis of symmetry is at the input of 1, so that's what I have to use. G of 1 is equal to 2 times 1 squared minus 4 times 1 minus 30. So that gives me G of 1 is equal to 2 times 1 minus 4 minus 30. G of 1 is equal to 2 minus 4 minus 30. And so that gives me that G of 1 is equal to -2 minus 30, which gives me -32. So given that I'm now looking at the vertex, which is now taking into consideration the output value, and we recognize that both of these have absolute mins because they have concavity. That means that which vertex is actually lower? This one's going to be lower, which means that this vertex here is greater. Remember, the alligator always opens to the greater value. So we've so far looked at the y-intercept, feature, concavity, it's the specific behavior, axis of symmetry, which is another very important feature, and the vertex. I'm going to go ahead and continue on. I'm going to put this a little bit up. And I'm going to talk now, and just like that, continue on my little chart. And we're going to talk at a specific input value. Let's say we want to look at an input value, x equals 8. So I'm going to look for f of 8, which means, again, I'm going to take that function, and wherever there's an x, I'm now replacing with an 8 to find the corresponding output. So I have 8 squared plus 2 times 8 minus 3. So that tells me that the function at the input 8 is going to give me 64, because 8 squared is for 64, plus 16 minus 3. This gives me f of 8 is equal to 64, 74, 80 minus 3 gives me 77. I'm going to do the same thing over here, looking for g of 8, which is now, let's see, 8 squared minus 4 times 8 minus 30. I get g of 8 is equal to 2 times 64 minus 32 minus 30. G of 8 is going to give me, this is going to be 128 minus 62. So let's see, 128 minus 62. That gives me 66. So here I get g of 8 equals 66. So if I'm looking at this comparison, we can see that this function has a greater output. So f of x has a greater output than g of x when we're looking at the input of 8. And that's specific input and output comparison. Now I'm going to talk about average rate of change. So let's remember average rate of change looks at an interval, right? So if I have an interval, it's an interval of inputs. So it's a particular portion of the domain. Let's say this is the starting value, the starting input, and this is my ending input. Okay? So my average rate of change formula is going to be, I'm going to call it M because it is slope. So I'm just going to use the same variable. It's going to be, I take the output of the ending input, subtract it from the output of the starting one, and then I divide that by the difference of these. And it's always last over minus first. You always start from the end and you go back to the beginning, okay? So let's go ahead and see. I'm going to give you an example. I want to figure out, so that's just a quick little crash course. We've done this already. I want to figure out the rate of change between the interval of 0 and 3, okay? So the very first thing I have to do is I have to figure out what is A, what is B, what is f of A, and what is f of B for both of these functions. So this is A and this is B. So we recognize A is equal to 0. I now have to figure out what f of A is going to be. So f of A is going to give me f of 0. See that? And then I'm going to, just making sure that you don't think that's a division sign. I'm just putting little borders so you understand. B is going to be 3, which means that f of B is going to be f of 3. So I need to figure out these values first so I can plug it into the formula and find the average rate of change. Okay, so I'm going to do the same thing for over here. My A is 0, which means G of A is going to be G of 0. And my B is 3, which means that G of B is going to be G of 3. Okay? So, given the paper is running out, let me just put my functions in here. So I have f of x equals x squared plus 2x minus 3. And on this side, I have g of x equals 2x squared minus 4x minus 30. Okay, that way I have room. Cool. So let's go ahead and find that rate of change for f. So first I have to find what f of 0 is. F of 0, I know that f of 0 is equal to negative 3. Okay, and I have to find what f of 3 is. So f of 3 squared is 9, plus 2 times 3 is 6, so 9 plus 6 is 15, minus 3 is 12. So I know that f of 3 is equal to 12. I'm going to do the same thing over here. So I know that g of 0 is equal to negative 30, and g of 3 means 3 squared is 9, 9 times 2 is 18, 18 minus 4 times 3 is 12, so 18 minus 12 is 6, and then 6 minus 30 is negative 24, okay? So notice that I found G of A and G of B, okay? So remember, this right here is f of A, this right here is f of B, this right here is G of A, this right here is G of B, okay? So by analyzing the same little interval on my graph, I'm able to find out how quickly the function is increasing at what rate, okay? So in terms of calculus, this is called velocity analysis. So let's go ahead and put it into the formula. Remember, my formula is this. I'm going to say the rate of change for the function of f is equal to, I will always start with the function formula first, just like I do when I taught you slope. And now I'm just going to plug in everything. I know my A, I know my B, I know my f of A, and I know my f of B. So f of B is 12. F of A is negative 3. Notice, minus negative 3. Divided by, what's my B? 3 minus 0. Okay? So 12 minus negative 3. Here comes my two-line rule. Crash course on two-line rule if you haven't seen this before. In order to take a subtraction problem and turn it into addition, it's easier to analyze. I draw two little lines. The first line changes subtraction to addition. The second line changes the sign of only the second number. So right there, I only drew two little lines, so now it's an addition problem. So 12 plus 3 gives me 15. And that one gives me 3. So that gives me 5, which tells me that the rate of change for this function in the interval from 0 to 3 is 5. Okay, I'm going to do the same thing over here now for g. So I'm looking at the rate of change for g at the interval from 0 to 3. This gives me g of b minus g of a divided by b minus a. What's g of b? Negative 24. What's g of a? Minus negative 30. Be careful with those double negatives. And then I have my b is 3 and my a is 0. Okay, so I get negative 24, two-line rule, plus 30 over 3 minus 0. This gives me 6 over 3, which is 2. That tells me that the rate of change for the function of g is 2 within that interval. So who has a greater rate of change? F does. Okay, and this concludes my video of comparing quadratic functions. I hope you enjoyed it. Now get to do your homework. May the 4th be with you, everybody.